Hey guys, so yesterday's lesson we progressed through 10 examples where we were just finding the area of a triangle, classic reliable 1/2 base times height. So in an example like example 8, which we had in yesterday's lesson, your base and your height are clearly indicated. While your triangle isn't a right triangle, you could always create right triangles inside of any triangle or outside of any triangle by drawing an altitude. An altitude can be represented by a dashed line which will run perpendicular to the line on which the base lies. My base is 9, my height is 8. 1/2 base times height, we got 36 units squared for the area for example 8. However, when you're faced with an example like example 9, you can't use 1/2 base times height right away. We can use it, but it's going to take a little bit of work on the side before we can really get this to work the way we'd like. The base is still pretty straightforward. The base is still 9. The height, however, is not drawn in for me. That's not really a big deal. We have all the tools we need to figure out this height. Now, I also want you to pay close attention to the information we're given at the start of this problem. We have a triangle where the information given to us is a side, angle, side. Whenever you have a side, angle, side triangle, and none of your angles are 90 degrees, you will not have your base and height clearly indicated. That means that any right triangles you want to use have to be put in by yourself. What I did is I drew in my altitude as a dashed line. That's where that question mark is highlighting. Then the triangle on the left side of the dashed line is redrawn to the right of the triangle for example 9. I took a minute to point out that that bottom measure of the leg is not 4.5. More often than not, I realize that people are making mistakes finding area because they're jumping to conclusions and assuming that the altitude is dividing the base, which it is perpendicular to, in half. Do you know when it cuts that base in half? It only cuts that base in half when you're working with an isosceles triangle where the two congruent angles are on the bottom or touching that particular base. Since we have no reason to believe that this is an isosceles triangle, we can't make the assumption that that piece is 4.5. Now, let's continue drawing this right triangle. I'm doing this problem, which does have numbers in it, as a specific case, a specific example. This is not a general example. General examples only use letters, variables, stand-ins. Specific examples have numerical values being used. In order to figure out the height of the purple triangle, for example 9, I'm using the red triangle drawn to the side. I have a 40-degree angle in the bottom left corner. I also know for sure that while the one leg adjacent to the 40-degree angle is not 4.5, the hypotenuse is definitely 8 units long. Since I know that the hypotenuse is definitely 8 units long, A equals 8 was given information at the beginning of the problem. I can use that to help me find the height. I have the hypotenuse is 8 and the acute angle is 40. I'm looking for H, which is standing in for my opposite side. Remember that right triangle trigonometry is SOHCAHTOA. Why am I repeating that? Because SOHCAHTOA is only supposed to be used when we have a right triangle. While we'll use trigonometric functions, ratios, and graphs for lots of things in the future, at this moment right now, we are focused on the ratios SOHCAHTOA. The sine of 40 degrees, that is our theta, equals opposite which happens to be h for height, over hypotenuse, which is 8, and that was given to us at the beginning of the problem. In order to get h alone, all we need to do is multiply both sides by 8. H equals 8 times sine of 40 degrees. We don't know the sine of 40 degrees off the top of our head, so we're going to use a calculator. When we use a calculator, we find that the height is approximately 5.1423, yada, yada, yada. We can use this value in our traditional equation of area equals 1/2 base times height. While this is completely acceptable and appropriate, using this method to find our area every single time could prove to be a little bit time-consuming. If we investigate this type of triangle a little bit further, this side angle side situation, we might find that we can create a formula all on our own and use that formula to figure out our area of the triangle without doing so much separate side work. The formula will take care of it for us. We're trying to make finding the area way more efficient. In math, we make things more efficient by using general variables, general terms, expressions. We don't use specific numbers. We can still use the exact same strategy we did before, but instead of getting the approximate values and using a calculator, we'll just keep everything in terms of these letters, and then we'll be left with a formula. 1/2 base times height is still the area of a triangle. 1/2 is a constant, so I can leave that just the way it is. The base is b, which appears to be given as just b in this situation. The height is still unknown, so I drew the h in pink, and now I'm still using the right triangle created by side A, the height or altitude, and the left side of that base side of the triangle. The 90-degree angle is in the bottom right corner, and angle C is in the bottom left corner. We're still able to use sine, which makes sense because we're given the same information, albeit quite general this time. Sine of angle C equals opposite over hypotenuse. So that means sine of angle C is h over A. I want to know, what does h equal if I'm only working with A, B, and angle C? When I multiply both sides by A, I find that my height will equal A times the sine of angle C. I'm going to fill that in for my height once and for all, so I don't need to keep doing side work to figure out the height before I find the area. Now I have area equals 1/2 b times A sine C. B times A is not in alphabetical order, so I'm going to just turn that around, and now I have area equals 1/2 AB sine C. Side lengths in triangles are represented by lowercase letters. Angles will be represented with capital letters, which are the vertices of our polygon, or in this case, triangle. This is a formula for finding the area of a triangle when you have side, angle, side. Let's take a look at this just one more time, where you can just concentrate on what it is that is being done so you understand where the formula comes from. Once you really understand where the formula comes from, you can use it as much as you want. Also, pay attention to how I'm labeling the letters for the sides and angles of the triangle.